You were listening to a discussion on release of high-yielding, climate-resilient and bio-fortified varieties of crops to boost farm yield. The participants were Dr. D.K. Yadav, Additional Director General, Indian Council of Agricultural Research, and Arjun J. Chaudhary, Anchor. This program was produced and presented by the News Services Division of Akashvani. You can listen to it on our mobile app, News on AIR. This program is also available on our YouTube channel, News on AIR Official. You may share your feedback about this program through email at airnsdtalks@gmail.com.
This is Akashvani. In the weekly program Current Affairs, now we bring you a discussion on India and the space sector. The participants are Dr. B.H.M. Darukesha, Scientist, Indian Space Research Organization, and Pallav Bagla, Senior Science Journalist. Moderator is Diksha Saxena, Akashvani correspondent.
The Indian space sector has undergone a significant transformation over the years. Indian Space Research Organization ISRO have the successful Chandrayaan-3 mission, which achieved historic soft landing on the south pole of the moon, and the Aditya L1 mission, India's first solar exploration endeavor to their name, and now the organization gearing up for the Gaganyaan mission. To discuss more on the subject, I am joined by two eminent experts today. Welcome to the program.
Namaskar, thank you.
Namaskar Diksha, thank you.
Before we discuss the space sector in detail, I would first like to congratulate ISRO for the successful launch of EOS-08 Earth Observation Satellite in Sriharikota today.
Congratulations to you, congratulations to everybody, all Indians, and it's a great moment for all of us.
Mr. Bagla, for the benefit of our listeners, I would like you to explain different types of satellites, and I would also want you to talk about different launch vehicles.
Well, first let me congratulate the Indian Space Research Organization and India for having successfully launched both the small satellite launch vehicle, the Earth Imaging EOS-8 satellite, and the co-passenger which went into space this morning. This was the third developmental flight of the small satellite launch vehicle, which I sometimes call the Chota Bheem, and the small satellite launch vehicle is now ready to be commercialized, is what the Indian Space Research Organization says. Now, to answer, there are several types of satellites and several types of rockets, and India has end-to-end capabilities both in rockets, satellites, and also in application. So India's robust space ecosystem represents all kinds of facilities, and we are state of the art where it comes to that. As far as rockets go, we have sounding rockets, which are very small. We also have the Polar Satellite Launch Vehicle, which is workhorse rocket, which has given us many successful launches, including Chandrayaan-1. And we also have the launch vehicle Mark III, which is our heaviest launcher, which I sometimes call the Bahubali launcher. And that is the rocket which gave us the success of Chandrayaan-3. And in between, we also have the geosynchronous satellite launch vehicle Mark II, a slightly lower weight launching rocket. And as far as satellites go, India makes its own communication satellites, India makes its own Earth imaging satellites, India makes its own navigation satellites. We make our own spy satellites, so to say, for surveillance. We have end-to-end capabilities, and all of this is to provide last mile connectivity to Indians, ISRO touching lives every day.
Dr. Darukesha, I would like to bring our focus to today's launch of EOS-08 Earth Observation Satellite. What is the objective of this launch, and can you also talk about the details of how it was made?
Today was third developmental flight of small satellite launch vehicle, the latest version of the launch vehicle developed by ISRO. So it has a capability of putting 500 kg payload into 500 kilometer orbit. Having developed this launch vehicle, it becomes the responsibility to prove its repeatability, robustness, and that is how SSLV D1, D2, D3 missions are conducted. Today's mission ensure that what we have developed is completely repeatable and we can go into commercial utilization or exploitation of this vehicle, which is likely to be taken up by Indian industry with NSIL in place. So this is the significance of today's launch. Today at 9:30, when it put EOS-08 into the precise intended orbit, it became clear that we have another launch vehicle that is commercially viable and we can use it. So this is about the launch. Say making of it, yes, as we know it is a three-stage rocket and then it has a small liquid unit which can be used to trim the velocity at the upper stage. It is modular, cost effective, its assembly is very quickly we can assemble this. It has features like say new control electronics, low cost electronics and then new separation systems. All in all, it can accommodate different types of satellites, and this is how it is going to be beneficial for the upcoming domestic and international small satellite market, Diksha.
Mr. Bagla, as Dr. Dharukesha spoke about the small satellite launch vehicle, how important is the role of private sector in enhancing India's space capabilities?
Well, the small satellite launch vehicle, this is right now for the Indian Space Research Organization's vehicle. It is likely to be transferred to more than one commercial entities. So this is what it will be. The satellite is very unique. The EOS 8 satellite, which has gone up. Let me dwell a little bit on the EOS 8 satellite. It's a micro satellite. It is just weighing 175 kilograms or so, and this packed with new technologies. ISRO has tested more than a dozen new technologies on this experimental flight of the small satellite launch vehicle with the experimental satellite, the EOS 8. It carries three different instruments to do various things, but more than that, it is a vehicle which will be used for proving several technologies which will go on to be used in our future microsatellites. The country needs more than 50 microsatellites in space, and this particular EOS 8 is a forerunner for many of the upcoming microsatellites which are going to be made by India, both for civilian and for defense use. Like Dr. M. Sankaran, the director of the UR Rao Satellite Center, told me, it's a trailblazing satellite. And this is what will become the bedrock for making modern small satellites for India when India goes in for constellations of satellites.
Dr. Dharukesha, can you speak about the role of private sector in enhancing India's space capabilities?
After the reforms, the space sector has been opened up for private entrepreneurs, essentially to exploit the talent that we have in India. They are going to the bigger partners, they will have to develop new technology, they are doing that. And as we know, about 200 startups have been registered. Space per se is not belonging to anybody, but it belongs to everybody. Space market is global. It's not that, okay, our new private players work only for India. They have the whole market of the internationally available market. So we hope with the help of say whatever hand holding ISRO is able to do, definitely we will be more than happy to do. With that, we wish that Indian space sector, Indian space realm grows further and we will be able to make a bigger and bigger contribution to the world space market.
ISRO has always worked with Indian industry. The Indian industry has been supplying components for our rockets and for our satellites, which is sub-assemblies or assemblies for our satellites and rockets. Under Prime Minister Narendra Modi initiated the reform process. The endeavor is that now whole rockets, whole satellites should ideally be made by industry, especially the ones which are to be made repeatedly and in very large numbers, which could be communication satellites, microsatellites, even the polar satellite launch vehicle, the small satellite launch vehicle. These repeat orders should ideally be met by the Indian industry. And towards that, the Indian Space Research Organization has worked hard to get the industry on board. The polar satellite launch vehicle is technology is already being handheld with the consortium to be launched. And same thing will happen for the small satellite launch vehicle and for the microsat. As far as startups go, there are several startups which are contributing towards making rockets like Agni and Skyroot. these are young startups, and there are also some startups which are making sophisticated small satellites. And there is a large number of startups which are working on applications. The big money really lies in applications, not just in making satellites and rockets.
Right, Mr. Bagla. Dr. Dharukesha, as we spoke about the importance of private sector, I would now like to draw your attention, Mr. Bagla's attention, to the small satellite market. I would like to ask you both, what are the prospects of small satellite market?
Diksha, as a curious enthusiast, when I looked at as of 2023, the small satellite market is about 15% of the whole market, and this constitutes to about $5 billion, which translates to some 40,000 crore rupees. And it is expected by 2030 that this will grow at a rate of say 12 to 15% to may it may reach billion US dollars, which is like 1 lakh crore rupees. So this is going to be a big market. And as Mr. Bagla was pointing out, the upstream, there is upstream and there is downstream. Upstream is taking the satellites into the space, and downstream is making use of these applications. So several new applications do not require heavy satellites, and several of them require a constellation of satellites. That is where small satellites are going to be unique, and this is where new and novel applications are going to benefit all of us.
Mr. Bagla, your comments on this.
See, the small satellite market in India still has to stabilize, and there has to be a demand for that. Right now, I personally see a demand for small satellites only from the defense sector. That demand has to come to the Indian Space Research Organization, and the Ministry of Defense is to be ready to foot the bill so that India can launch a constellation of small satellites which can do amazing Earth imaging and surveillance, because we have two very hostile neighbors, one on the west and one on the east, and both need to be kept an eye on. So there is a demand from the defense sector for microsatellites, and that is why today's EOS 8 launch is really a forerunner for several of the satellites which we may see in times to come. Subsequently, microsatellite and the IMS bus can certainly be used for different purposes and tailor-made by the startups to different applications like hyperspectral imaging or do synthetic aperture radar imaging for different purposes. So there is option there. But right now, I think ISRO is concentrating very heavily on the heavier satellites, and that is the bread and butter for them. And the microsatellite market still has to grow and become available for the startups to take it further.
Mr. Bagla, according to your analysis, how is ISRO cutting down on the cost of its space missions?
Well, see, India is known for low cost, frugal missions which are highly reliable. India's Chandrayaan 1, India's Mangalyaan, India's Chandrayaan 3 with Vikram lander and Pragyan rover, all done at very low cost, have shown how India can really do missions at budget cost but highly reliable. ISRO does not give out its hard numbers on how they calculate the cost, but there are several things in which ISRO is very nimble and the way they execute their missions. One, the personnel do more than one mission at a time. Secondly, ISRO normally does not make engineering models. They go directly to a flight model that trims the cost. And since these are missions executed by the government agency, there are no shareholders involved. When there are no shareholders involved, there are no profits to be shared. Like in America, most of the satellites are made by Boeing or Lockheed Martin or other companies, and their profits have to be shared with the shareholders. That increases the cost. And if you see, we have a mission called the NASA ISRO Synthetic Aperture Radar coming up. It's a joint mission between India and America, and the NASA component is almost 4 to 5 times more expensive than the Indian component, and that is because NASA's costs are high and the Indian costs are lower. And India knows how to do frugal technology and to do highly reliable missions. And that is one reason, and Dr. Darukesha will agree with me, which is why the United States of America wants to partner with India, if possible, on the Artemis program, because they have the technology, we have the way of doing low cost, same, making that technology, it's a win-win for India and America and for the world. It's a wonderful opportunity for the world to partner with India.
I would now like to move to Dr. Darukesha. How has the Chandrayaan 3 mission helped in studying the lunar surface?
If we consider the moon surface, we have two things that I have touched. One is Vikram lander. It has two major instruments, chaste, that can measure the temperature profile of the moon surface as it measured the gradient. Suppose a hole on earth, say 10 centimeters, we may not find much of a difference from the surface to about 10 centimeter depth. But on the surface of the moon, it is very, very drastic, and this is very encouraging because when you have two surfaces, hot and cold surfaces, you can connect a wire and then you will get the voltage. The second is the Langmuir probe. Langmuir is the name of a scientist, and this probe measures the plasma density. Because there is a 15-day daytime there, so it is in the morning, afternoon, evening. What would be the plasma density? If we can measure when we go to moon for landing, possibly we can go prepared. So fortunately, what the probe has shown us is that the plasma density is very normal and we don't have to really worry about that. Then the Pragyan rover had two instruments, alpha induced fluorescence spectroscope and laser induced breakdown spectroscope. Essentially, in one, the alpha is irradiated onto the surface of the moon, the fluorescence X rays will come. These X rays carry the characteristic energy. So, by measuring those energies, I know these elements are available. So, similarly, in the laser induced spectroscope, the laser is made to irradiate onto the surface. The material goes directly into plasma state. The color of this plasma, or in other words, the wavelength of the light that comes, is characteristic to the material. This is how, as expected, the surface has been known to composed of oxygen, silicon, iron, aluminum, but very, very interestingly, sulfur has been detected in the southern polar region of the moon. It is unexpected because how did sulfur came there? Did it come from the moon's bottom, or did it come from a meteor, or the composition of the material got changed here? So this is what has been shown and known about the lunar surface through the Chandrayaan 3 Diksha.
Quite interesting, Dr. Darukesha. Could you also talk about Chandrayaan 4 mission, which was announced by ISRO earlier this year? What is the aim of this mission?
This mission is a sample return mission. We landed on the moon using Chandrayaan 3. Then, in the next extended version, this mission is to bring the sample of stones, soil from the surface of the moon and bring it to the earth for further study. So, this is a technology demonstration as well as extension of what science we have been doing.
Chandrayaan 3, by landing closer to the south pole of the moon, created global history. So anything which is found and studied is going to be new for understanding the moon's geology. Now, next step is obviously to bring a sample back from the moon, and something which has been done since 1969. So that's not surprising. But Chandrayaan 4 is really, in my opinion, a forerunner for what India is going to endeavor in the next 15, 16 years. Prime Minister Narendra Modi has already tasked Darukesha's organization that we have to land an Indian on the moon by 2040. So if you have to land an Indian on the moon, there are many technologies that need to be tested. And Chandrayaan 4, with its sample return mission, will test many of the technologies which will go on in an enlarged scale to be used when an Indian is sent on the moon and brought back. So Chandrayaan 4 is a forerunner for landing an Indian on the moon, which would be a glorious moment.
Indeed, Mr. Bagla, I would completely agree with you on this. It would be a glorious moment for the country. Mr. Bagla, now I would like to talk to you about the most awaited Gaganyaan mission. Can you please explain the mission for the benefit of our listeners?
The Gaganyaan mission, India's single most expensive scientific experiment ever to be undertaken. It will cost about rupees 10,000 crores, and the government has already sanctioned it. And the aim is to launch an Indian on an Indian rocket from Indian soil, take a person into space, and to bring them back safely. And towards that, the Indian Space Research Organization is working extremely hard to make sure that we have all the technologies in space, and India for its Gaganyaan program, and India calls its astronauts Gaganyatris. Four Gaganyatri designates have already been chosen. These are Indian Air Force test pilots, and they are being trained. First, they were trained in Russia, then they trained in France, and now they are training in America, two of them. And the Gaganyaan program will send an Indian into space using the human space version of the launch vehicle Mark III into a low Earth orbit on an Indian crew module and then bring them back safely to. This is essentially making sure that India has the technology to send Indians into space and bring them back. It's a very important technology. We certainly cannot rely on other countries for having access to space. So this is Gaganyaan mission is a very, very important mission. And the effort is to try and do that sometime next year end or early 2026. The last country on independent capability to send a human to space was China in 2003. And after that, no other country has achieved that on the independent capability. So India will be the fourth country after Russia or Soviet Union, America, and China to have independent capability to send humans to space and bring them back on their own indigenous technology.
Mr. Bagla, as you spoke about it and you said that we would enter the league of the few countries who have done this in past, I would like to ask you what took us so long to go for this mission?
Well, I spoke to Dr. S. Somnath very recently about the Gaganyaan mission and as to why is this happening, say, end of next year or early next year. So his answer was very simple. Yahi samay, sahi samay. So there was need, and this is the right time. We needed the technology, we needed the political will, and we also needed the complete support of the Indian Air Force and the Indian public to undertake the Gaganyaan mission. And whenever you do it, it is the correct time.
The Gaganyaan is not going to be one of its endeavor type, so it's a continuation. It would help us in building the Bharatiya Antariksha Station, landing an Indian on the moon, and more interestingly, the experiments that we might do in Gaganyaan or Bharatiya Antariksha Station are going to be really beneficial. There are several experiments planned in microgravity, biological samples, say for example, seed mutation. It is said that by say engineering the mutation, possibly we might get proper seeds, and no other country may help us in getting a proper mutation or engineer the mutation for Indian crop. So this is where having our own station, our own Gaganyaan will help us conduct these science experiment for our utilization.
Can you please explain how ISRO is ensuring the safety of who are a part of the Gaganyaan mission and who would be in space for a certain number of days?
The most sophisticated equipment ever sent to space is human being. So in all these missions, utmost care has to be exercised to ensure that we bring them safely so that we continue this project for further several years. Just like our aeroplane flights, taking off and landing are the two times during which we might expect several challenges. So to overcome or to ensure that we have overcome these challenges, suppose there is a problem on the pad, launch pad itself. How do we safely bring back or safely recover the crew? Then the next stage is when the Gaganyaan launch vehicle passes through the gains a velocity of that of sound. That's where the highest level of vibrations and shock is going to be experienced. In such case, crew escape system will come to rescue. Upon receiving the command, this crew escape system will pull away the crew system and it will go to another 5-6 kilometers away and then it will land. Next stage is when they are returning. We will be using several set of parachutes and there is a sequence in which the parachutes have to open. And now the question is this: what if one of them is not opening? What if the sequence is changed? To test that we will be safely landing in all these permutations and combinations, the tests are going on. Hopefully we will complete those tests soon and we will get on with the mission.
Mr. Bagla, as Dr. Darukesha spoke about the safety, I would like to ask you your insights on the training which the astronauts are currently undergoing for the much awaited mission.
The four astronaut designates are all male Indian Air Force test pilots. They know the risk They understand how to fly machines. So it's just going the next step, which is to go on a spacecraft which has been made in India and they have themselves helped design and then go to space and come back. ISRO is making several safety measures in place. Both the rocket, the launch vehicle Mark III has been human rated, which means that many redundancies have been added. Same way, the crew module, which is still being designed, is also going to be made very safe. India is going to be using Russian made suits for this particular maiden launch, and these seats also will be Russian made. But at the end of the day, it is all about making sure that the environment control and life support system, which is being designed by India for the crew module, works very efficient. And finally, I am sure the Indian Space Research Organization will undertake human crewed flight only when all systems have been tested and when the reliability is over 99%. So there is a very strict requirement, stringent requirement, and ISRO will do everything that is required to it. The astronauts have already been trained as in the Russian Space Agency. They have also had training with the French Space Agency on medical grounds. Currently, two of our astronauts are at NASA training, and one of them is likely to go to the International Space Station on a joint NASA ISRO mission, which is likely to take place sometime towards the second half of 2025. So there is a lot of training which is going on of the astronauts, and India has rightfully chosen a very young astronaut as the prime astronaut, 39-year-old Group Captain Shukla, and he has 20 years to contribute to the astronaut corps. So it is all about safety, and we are seeing that right now even as astronaut Sunita Williams continues to stay longer than expected at the International Space Station. Her return is delayed simply because of safety issues.
Dr. Darukesha, I would like to ask you about the Bharatiya Antriksh Station BAS, which is supposed to be ready by 2035. Could you just briefly talk about it and how is ISRO preparing for the BAS?
Diksha, these designs are preliminary stage. There is a lot of discussion going on. The designs and further details will flow possibly at appropriate time. As we can say, contemplate, it would be a station which is going to have several sections in which pressurized module, unpressurized crew module, and then the scientific experimental module and things like that. So further details will flow maybe through our website and social media, Diksha.
Mr. Bagla and Dr. Darukesha, I would like to ask both of you now, how is ISRO, the government, how are we inculcating the interest in the space sector? What are we doing to encourage the new generation to take interest in this very vibrant and ever growing sector?
ISRO centers can be visited by students, and those museums at Tirunanthapuram, Ahmedabad, any age group can simply walk in. Other places, students will have to write to the concerned officials through their school principal. They will be allotted a day wherein they can come and visit. All these details are there on our website. And those who are studying in the 9th standard, there is Yuva Vignani Karakram, Yuvika. About 7 centers will host 50 each students for a 15 days residential program wherein they will be exposed to various facilities and the missions. Next is IIST. It's an engineering college where students can join, do their MTech, PhD, and further professional students might get opportunity for project and internship. Next is students and professors, academicians can apply for research, sponsored research, that's a respond program, and they can actually work on the projects that are of interest and importance to ISRO. Beyond this, school children, college and universities can build their own instruments, sensors, payloads, satellite itself. ISRO will be very happy to launch. And then beyond this, the startups. So ISRO will be very much encouraging the new startups. These are the methods in which people, further forthcoming generation, can get enthused and engaged with Indian space program.
Mr. Bagla, your views?
Well, very straightforward. Nothing succeeds like success. And ISRO has shown that it can repeatedly show success. It showed success with communication satellite. It showed success with Earth imaging satellites. It showed success with interplanetary exploration, which is Chandrayaan 1, Chandrayaan 2, Chandrayaan 3, and also with Mangalyaan. So there is tremendous excitement among the youth and the public all about ISRO's activities. And I'm sure Dr. Darukesha finds it very